Okay, we're live and the sound is working this time. So I have no viewers and no questions. Still no viewers, still no questions. Aha, I have two now. So I'm still waiting for questions. There is no question yet. So I do hope that the three of you now have any questions, because otherwise this is going to be a very uneventful office hours. So I got this question about does it make sense to hand assemble a version of Hello World C with no libraries to be able to get a better idea of what the simulator is doing? The answer is whatever helps you understand things better is of course useful, but you know, over the years I haven't had any students try to do something like, you know, program in assembler by hand or something like that. Usually if you're trying to kind of figure out, you know, MIPS assembler and, you know, what happens in it and stuff like that, usually it's kind of beneficial to do the opposite, which is you know, write some small C program function and then you know, have it assembled by the compiler, and then basically look at the assembler code that it generated to see kind of just, you know, what normal C operations usually do in the MIPS assembler. But I'm not sure whether branch prediction and its behavior are, you know, better understood if you actually do things in assembler versus when you do it in C. What you also could do actually, if you want a simple program so that you can try to do something like, you know, let's just make a loop, but you're worried about the compiler optimizing it out and so on, you could try to lower the level of optimization by just, instead of -03, you could do something like -0, which removes almost all the optimizations, and then try it that way, if that answers your question. So this is a question about, you know, what's common in current processors. Both hierarchical and tournament predictors have been used. Currently, hierarchical are a lot more popular just because that they allow you to essentially have a very complex, very fancy predictor, but because it's so complex and fancy, the cost per branch that you're trying to predict usually is very large, because you basically have a lot of counters that correspond to the same branch with different histories and so on. So usually hierarchical is useful for that, because it allows you to basically, you know, easily predicted branches kind of go to the cheap predictor, and only the big ones go to the hierarchical, only the big ones that are difficult to predict go to the, you know, more sophisticated history-based predictors and so on. So because of kind of the energy savings and also the kind of you know, you don't want to throw your best predictor at every branch, hierarchical are much more popular nowadays. Also, we have actually seen now, you know, a lot of the processors have more than one predictor, I mean, more than two predictors in a hierarchy. So it's not only like, you know, kind of the simple and complex one. Oftentimes it's either the kind of the simple, and then there is a hierarchy with like the simple. If that doesn't predict well, then we use, for example, a tournament predictor, or even we have seen things like, you know, simple, less simple, and then more complicated and so on. So almost every processor nowadays has some sort of a hierarchical predictor, and then some of them actually still have a tournament predictor as one of the components in it. So let me see the next question. Oh, this one is, it's taking a while to select the questions. So this is a question about the description. If the prediction in the local table is not fully saturated, we will consult and update if needed the global table predictor and use this decision as the final one. Actually, that's not what that's not exactly what the assignment says, but basically the question is about update if needed. The predict method, if you look at, for example, the BP hybrid, the predict method has a parameter that says do update. And if that parameter is false, that means that you're supposed to generate the prediction and then not update the predictor. Only if the do update is true are you supposed to generate the prediction and then update the predictor. So that's why update if needed. Update if needed is there because you shouldn't update every time. You should update only if the do update parameter to the predict method is actually saying to update. Now, one thing that is kind of related to the previous answer that I haven't been asked, but I've noticed that in Piazza there has been several questions about that. So essentially, your predictor, basically the do update method, when it's true, be careful how you update the predictor. Okay, you're supposed to first read out for example, the counters and histories and so on, and only then update them. So basically, don't base your prediction for the branch on updates that are dependent on its own outcome. Okay, so pretty much kind of you can update one predictor before you kind of consult another one and so on, but just make sure that in the prediction for the current branch you are not using history and counters and so on that you have already updated with the outcome of that very branch, because you could make a very good predictor by kind of first updating with its own outcome and then of course checking the predictor. But such a predictor, of course, would be not valid, because in a real processor, what's happening is you have to make the prediction without knowing the outcome, and only later you know the outcome and you can update the predictor. In the simulator, it's just by design. Basically, we wanted to kind of simplify it, so the predict method is doing the update just so that we don't have to have another method that does the update. Okay, now I'm waiting for more questions. So for those of you who are just joining in, and I have seen there is a question of how to submit the question. So basically, if you look, there is a Q&A gadget, and in it you can submit the questions, and then I see them and I can answer them. So if you email me, currently I'm not checking my email, so that's going to wait until the next office hours, which will be on Friday. Oh, so there is another question. Great. Okay, so this question is about, should we grab the saturation parameter before we grab a prediction? And the answer is not necessarily before you grab the prediction, but definitely before you basically, if you call anything with your do update, then that something will be updated. So yes, you should. I mean, basically you should grab the prediction. Read out whether it's saturated and so on before you tell it to update itself. because both the global table and the local table are actually going to be updated if you call them with the second parameter, which is basically the outcome. So if you call the global table or local table predict, and you call them with only one parameter, then they only get read. But if you call them with the kind of index comma outcome, then they do get updated. So definitely basically check the saturation and so on before you do that. So in the current code for the BP hybrid, there is a do update, and then there is a if do update, then call with the parameter that tells them to update. If do update is false, then call them without that parameter. So pretty much if you're doing something like that, then definitely check for saturation counter before you do something like that. This is not really a question, but yes. So if you're asking a question, make sure you're logged into Google. Otherwise, apparently it doesn't work. At least that's what one of the students says. Thank you. Okay, so let me check the document because I just need to verify something. Yeah, I cannot find it this quickly, but I think it had to do with the local or global table. Basically, I don't see a question anymore, but I was just worried about whether it's the local or global table. So just make sure that you understand which table does what, because as you can see, the global table is the one really indexed with the L2 index, which is derived from the history, which should be telling you something about which table is which. So there might have been a typo in the document, but I will have to check it later because I don't want to spend too much time now debugging it. Oh, I checked. Yes, actually, what you quoted for the document is fine. Basically, the local table is the one consulted first, and that's the one you check for saturation, and you only really do anything with the history and global table if the local table decision is not based on a fully saturated counter. Sorry to confuse this a little bit. I checked because I had no questions. So if you submit more questions, then I can answer them. Okay, still no. Question. I'm not sure really I understand the question, because it's not really about the kind of get saturation, get prediction, and then update the table and the counter. It's really that when you check the saturation, it's not updating the predictor. It's only checking whether it's fully saturated. The get prediction part and the update the table and the counter part are really when you call the global table predict and you pass the taken parameter. If you look at the BP hybrid predict code, that's kind of how it's done. So on do update, what do update is what it's going to do is it's reading the global and the local table and checking their decision and passing the taken parameter as the second parameter, which is taken really is whether the branch is actually taken, should be taken. So this is kind of the correct outcome. So basically that way, the predict method on the global and local table really is doing both the kind of returns the decision of the prediction while also updating it. And if you take a look at how that code is working, it's actually first determining what the return value should be for these methods, and only then updating the counter. So basically, don't get the prediction and then update unless you are sure that the prediction you're getting is not also doing an update, because otherwise you will be actually on every branch updating the counters twice. So pretty much, take a look at how the BP hybrid is doing it, and you can do it almost the same way. Oh, this is a good question. I haven't thought of that, but you should leave them at not taken, because initialization of predictors with something other than some sort of default value is extremely complicated. So that would be kind of like, it's not fair to assume that the counter will be able to do something smarter than just kind of initialize with some sort of random value. And the not taken starting point for everything gives us a relatively good, kind of a stable point, so that we basically we could randomly initialize. But that way, every simulation will be different, which is an nightmare for debugging. So the not taken initialization is there to kind of provide something that we can debug. So please don't modify it. You should not be actually messing with, for example, the global table and local table and so on. Leave the saturating counters implementation as it is. This is a good question. Yes, your hierarchical predictor actually should have a prediction rate that is slightly better than the 2-bit predictor. And I mean, the 1.5 IPC actually, if you run this with a 2-bit predictor, it might be that it gives you actually a lower IPC. I'm not going to comment on the Oracle predictor, because again, you can run a simulation with the Oracle predictor and get exactly what the IPC for that is, and you actually need to do that for the assignment. So I'm not going to tell you what the numbers for that are, but the thing that you have to achieve with your with your new hierarchical predictor is basically that you need to get the IPC of 1.5, regardless of what you get when you run it with the hybrid and with the Oracle predictor and so on. So it could be, for example, that this is actually somehow better than the Oracle, yet you should still be able to get it. Why do we use saturation to tell if the prediction was correct? We are not really using saturation to tell whether the prediction is correct. It's basically that in the real predictor, we don't know whether the prediction was correct, but we have to decide whether we believe the simpler predictor or whether we should consult the more complicated predictor. And one of the ways to test whether the simpler predictor is likely to be correct or not is to kind of check how convinced the predictor is that what it's giving us is correct. So if, for example, with the 2-bit counter, the value of 0 is called strong not taken. That means that the predictor strongly believes somehow that the branch will not be taken. And even when it sees a taken branch, it will bring the counter to a state of 1, which means predict not taken. It's just that it's less convincing. So basically, the predictor needs to, if it's thinking that it's strong not taken, it needs to see two taken outcomes at least to start predicting taken. Why? Because it was so strongly convinced. Basically, the meaning of the kind of strong not taken is that we are so strongly convinced that it should be not taken, that even when we see the taken outcome, we will not start immediately predicting taken. Okay, so basically, the saturation here is used more of as an indication that the simple predictor thinks it knows what it's doing, rather than whether it's the decision is correct. Basically, we are kind of assuming that if the value is not saturated, that means that the simple predictor has seen both kinds of outcomes and it's not really sure what to output, but it has to tell us something. So it's telling us, for example, weak not taken is still a not taken, right? So basically, in those cases, we are going to consult the more complicated predictor because it may know better than the simpler predictor. So the saturation is used as more of a, how sure are you that you're giving me the right answer? Because that's about all you can do at that point. You don't really know whether the answer is right. What you can know is basically how saturated the counter is. Because if we have always been seeing not taken outcomes, then the counter will be in the strong not taken state, and we probably don't need to consult the more complicated predictor. But if we see kind of both taken and not taken, and we have seen both outcomes recently, then we probably need to ask the more complicated predictor. I hope that answers the question. Now there are no questions. So again, if you have one, send it. So for those of you who might have joined later, so there is a Q&A gadget on the Hangouts on Air that you're watching, and basically, if you go there, you will be able to both post a question and see what's the question being answered and so on. Because we still have no questions, so I'd like, I see I have 3 viewers. I don't know if you're actually watching, but if you are, I would actually appreciate if somebody commented in Piazza whether they were able to see this. I mean, if there are any significant problems, like for example the video is really bad, or you don't hear the sound or something like that, then please do comment, because according to what Google Hangouts on Air is telling me, everything should be working fine. So if something is not working fine, then especially if like the video is chopped, or something is wrong with the sound, or you cannot understand what I'm saying, then please post about it, or send me a note or an email. Oh, that's interesting. So it says video is pretty bad with high echo. Let me check the sound settings, because I mean, I'm not hearing any sound, so it's. Okay, so I've tweaked the settings somewhat. I don't know if there is any improvement, but that's the best I can do because I actually don't hear my own sound, so I don't know why there would be an echo. Friday was better quality. Yeah, that's. I mean, on Friday I was in a conference room. That's how I ended up running out of battery because I was not plugged in. Today I'm in my office, which is a smaller office with a higher ceiling, so that might be causing some of the problems. So I'll try to actually use a more directional microphone next time. Thank you. Okay, so let me tweak some more things. I'm using a microphone array which actually should be doing really well. Okay, so now I've enabled about as much of the echo cancellation as can be enabled in the app, and if that doesn't help, then I really don't know what to do other than start using a different mic, which I'll try to do that on Friday. I just don't have one with me. So this is saying that it takes about a minute or two after we submit a question for me to see it. That's yeah. I don't know what's going on there. I mean, it could be the whole Hangouts thing takes a while to update. Not much I can do about it. Last time I actually tried something like Skype. The problem is that you get no video, and it seems like it kind of helps to see me when I'm explaining things. So what we could try is do something like Skype where we can just like all talk or something like that. And also in Skype, and I've also tried. What was it, the WebEx, it becomes kind of difficult for me to manage who's going to talk and so on, because students can ask questions by kind of using voice. And if I do that, however, then very often I kind of have to mute a lot of the students, because some of them will have things going on in the background and so on. So it becomes really annoying when there is more than a couple of people basically whose mics are on at the same time. But I'll try to see if something can be done about the kind of microphone and the delay. I'll try to connect using the wired network next time and so on. So at this time, for example, I'm seeing no questions again. So this question is about whether the modification to make your BP hierarchical from BP hybrid should be relatively straightforward. I mean, it is relatively straightforward, as in, if you copy the code, essentially, it's kind of less than 20 lines worth of change. Probably not even that if you're trying to save the lines. So I'm not sure whether that kind of qualifies as not very complicated. But yes, I mean I mean for me it was basically, once I figured out what I wanted to do, it was something like a 10-minute thing, including the compilation and so on. But I was kind of lucky that it worked on the first try. I didn't need to like debug it. It didn't crash or anything like that. So you'll have to do it more carefully. But yes, I mean, it should be a relatively straightforward modification. There is nothing too tricky about it, except the part where you need to check for saturation, which I kind of told you how to do. Oh yeah, and then much of what the BP hybrid predict method is doing, you kind of just keep it. So for example, there is this whole part at the beginning of the file. Like I can actually kind of, I'm looking to the side because I have the code on the monitor next to me. So for example, the whole part about the bpred energy inc, that is the first line of the predict, and then the if in this branch taken, then just use the btb predict, and then the bool taken equals something, the IID equals something. I mean, you can just leave that as it is. The L2 index equals GHR, and then the do update of the GHR and so on. That's again, you can just, a lot of the code from the BP hybrid can be left as it is. You have to remove all of the stuff that kind of talks to the meta predictor, and that also can change, but it's really just kind of cut it out and so on. So the question is it okay that the BP hire class still accepts the parameters for the meta table, even though the meta table has been removed? The answer is yes. I mean, I will not test your code by kind of changing the configuration file to not have the meta table parameters. It's just that you should be aware that even though you are kind of still leaving the parameters and still reading them and so on, they are no longer going to actually, I mean, they should not affect your predictor. So for example, the actual meta table should be removed, but you could read the meta table parameters and just, I mean, you could still, for example, verify the meta table parameters and so on. Just please don't actually create a meta table, because then it's kind of going to be unclear to whoever is grading, and it's probably going to be me. It's going to not be clear whether you kind of knew that there is no longer a meta table, you just kind of left the code there anyway, or is it that you didn't know it and you thought that you actually had a meta table. So to avoid confusion about that, please remove the actual meta table from the for example the constructor and so on. But if you leave the parameters, that's fine. Again, no questions now. As I remember things, there shouldn't be, because I mean the only change I thought might be needed in other places is to basically check for saturation, but there is actually a way. I mean, it already has methods that check for. Unfortunately, there is no method that just checks for any saturation. There are two methods. One checks for kind of saturation down, the other one checks for saturation up. But if you use these two, I think the bpred CPP and bpred H are the only changes needed. Unfortunately, I did my own modifications more than a month ago, so I'm not absolutely positive about it. But as far as I remember, there shouldn't be any changes anywhere else. If you do need significant, I mean, if you need some sort of a trivial change somewhere else, maybe it's okay. But if you need anything meaningful in other files, then you're probably doing it wrong. I actually think that the only change I did was essentially to remove the meta table from the constructor and the declaration of the predictor and so on, and then basically the rest of it was confined to the predict method. Oh, actually, yeah. Now that I'm looking at the code, another place that you'll need to make some changes, and I think the document that I kind of put the project one in is, of course, at the end of the bpred, CPP, there is a place where it's basically checking what kinds of predictors it's supporting. So just make sure that your predictor is added to basically the B predictor, get bpred. You need to add your own predictor, basically the BP. The BP higher needs to be added to that. Now it's taking more than 10 seconds to select the question. So yeah, things appear to be slightly slower then. Huh? Okay, I think it got officially got confused. So the question is whether there is any additional resources for walking through the simulations of code for pipelining to Masula, et cetera, et cetera. There are a lot of online resources that kind of, for example, there are visualizations of pipelines. There is actually visualizations of Tomasulo's algorithm and so on. But I mean, a lot of them are maybe doing more harm than good, because they are all done under some assumptions, and then they're sometimes not really saying what the assumptions is. So if they slightly disagree from what for example an exam problem is, or something like that, it could be that basically somehow a graphical simulator, oftentimes you kind of learn from it basically, but you're not aware that that's just one possible way of doing things, and then you kind of get the problem, and then you don't understand what's going on. So basically, it's fine to use them, just be careful about understanding what in my lessons there are a lot of things that, for example, what can happen in the same cycle. Can you, for example, issue the instruction and then dispatch it in the same cycle? Can we forward and then issue an instruction and then dispatch an instruction, and so on. So just be careful about things like that. But there are actually a lot of online resources about kind of these simple things like Tomasulo's algorithm and so on. For simulators, for kind of for example, the one we are using for projects, there are a lot of simulators. They're all fairly similar in kind of the conceptual how they do things, but unfortunately, neither of them. None of them is really kind of kind of like a de facto standard that we can use. So basically, almost every professor will kind of have their own chosen simulator, and that's primarily because they're kind of the most familiar with it, and it's easier to help students with it than with some other simulator. But I am not aware of much like help about any of these simulators. Pretty much all of them are kind of derived from some sort of a research simulator that is not overly well documented to begin with. I'm not sure what you mean by reporting simulation data for each cycle, because on exams and things like that, basically, I tend to give problems that are either kind of do cycle by cycle things for like a really few cycles, because it's kind of tedious, or just ask you to kind of figure out what happens in which cycle, and that you can do kind of at a slightly more conceptual level than by actually kind of playing out the simulations. So I'm not. I need to think about maybe how to kind of in my lessons I've actually gone through one example. So for example, how to do, for example, Tomasulo's algorithm or an Arabic-based processor, kind of just keeping track of the timing of things without really kind of having what exactly is in the RAT and stuff like that. But if more of that would help, I'll like to see if I can do something like that during some of these hours or something like that. But unfortunately, you really don't want to use a simulator for something like that, just because most of the simulators, including the one we're using for the project, are kind of designed to model much more complicated processors. So to configure a simulator to kind of get similar behavior to, for example, what we will encounter in exams and so on would be relatively difficult. I've never actually like dumped out the, for example, kind of the renaming behavior of the simulator or something like that. Although you might be able to learn something from it, but it's kind of tedious to actually try to, for example,
Okay, so I lost the connection a few minutes ago for some reason, and it just kind of successfully reconnected after a while. Unfortunately, it looks like it lost all the questions. So so if you kind of, I mean, I'm not even sure whether this is properly connected anymore. It's saying that it's live and so on, but I'm not sure how it worked. Oh, okay. So I'm going to display this. It's not really a question, just for participant to see, I guess. Yep, Google lost both video and audio because it dropped me out pretty much. I was disconnected, and for 3 minutes it wouldn't connect. So I hope now everything is fine. We still have about 7 minutes to go. I have a meeting at 4, so we'll have to end unfortunately kind of on the hour, but so far I'm not seeing any questions other than the kind of comment that the video is back. Yeah, the Google reaction time for some reason is really slow. Like pretty much I select a question, takes about 10 seconds for it to appear in the currently answering thing. And then when I click done, and I clicked done on this one a few minutes ago, like 15 seconds now ago, and it's still there. The internet at Georgia Tech has been acting up in the past couple of hours. Nothing major, but it seems like the connections have been dropping, and then kind of like if you have Wi-Fi, pretty much it kind of disconnects you, and then 10 seconds later reconnects you and so on. So I'm not sure whether that's kind of related to the problems we're having, or is it something related to Google. But we'll see next Friday. Okay, so all the questions have now been answered, and I don't see. Oh, okay. So now I can actually select the question that I started answering when we dropped out. So regarding the kind of preferred method for kind of keeping track of things and so on, yes, I mean you usually it helps to draw kind of like a table that I did in the lessons, where basically you have a kind of like a row for each instruction, and then kind of a column for everything that happened, for kind of when does it issue and so on, and you kind of put cycle numbers in there. And then it does help to keep track, for example, of some of the resources. Like for example, if the reservation stations, for example, it helps to keep track just when do they become free and available, so that, for example, if we cannot issue because the reservation station is not available, kind of when that's going to go away. So you don't have to really kind of draw everything that we draw for Tomasulo's algorithm, but you kind of keeping track of just how many resources are available, so that when the number of available resources is 0 for something, you kind of need to know that. So it usually helps to kind of just do that, basically, kind of just keep a running count of how many reservation stations do I currently have available every cycle, how many ROB entries do I have available every cycle. Cycle, remember that you did that the same cycle. You don't accidentally send it for execution if that's not allowed, and so on. So I'm still not seeing any new questions. Unfortunately, it might be because there is some sort of delay. So I mean, I'm not sure whether you haven't submitted them but I don't see anything, and we should probably be wrapping up because I need to do a conference call in 2 minutes now. So if I don't get any questions in the next minute or so, then I'll probably have to say bye-bye. And there will be the normal office hours on Friday. So we'll do that. Aha, finally the question I selected is there. So I've already answered this one. Next time I might do this from home because apparently I have better internet than at home than at work. Another thing that because I'm not sure how apparently the video is working, is just that the whole question and answer application is kind of having some trouble. So for Friday, if you do have questions, just basically when you find the office hours entry in Hangouts on Air, you can actually kind of post things there. So I'll read those posts before I begin the office hours. So if you have any questions that you really want me to answer, and you have them kind of before the office hours begin, just post them there, and then I'll actually kind of ask the question myself and then answer it, so that you don't have to kind of submit a question here and then wonder whether it's ever going to get to me or something like that. So now I'll have to go. Thank you for listening, and again, if you have any questions, you can still ask me the others. So if Friday's office hours you have questions that you really want me to answer kind of live, then just kind of, you can even post that in Piazza if you want. Well, thank you.